This is Bob Capetta, and this lesson is on the difference quotient. Let's look at an example. If I have f of x is 3x squared minus 5x plus 2. And let's say I'm interested in seeing what, for example, what is f of c minus 4. How do we do that? Well, wherever we have an x, we replace it with a c minus 4. So I have 3 times x squared minus 5 times x plus 2. We're going to replace all of those x's with c minus 4. And then I've got to do c minus 4 squared. And what I like to do with that is I like to use my multiplication box. I prefer that to FOIL, although I know a lot of students like to use a tool like FOIL. I like to visualize the multiplication. So I have c minus 4 squared, which means c minus 4 times c minus 4. C times c is c squared. Negative 4 times c is negative 4c. Negative 4 times c is negative 4c. Negative 4 times negative 4 is positive 16. Add all those together, what do I get? I get c squared minus 4c minus 4c minus 8c plus 16. That's what c minus 4 squared is. So replacing that up here, we're going to get 3 times c squared minus 8c plus 16. Minus 5 times c minus 4 plus 2. And we need to distribute. So again, this is f of c minus 4 equals that. F of c minus 4 equals distributing 3 times c squared is 3c squared. Minus 3 times 8c is 24c. Plus 3 times 16, 30, and 18 is 48. For this minus 5, I like to make it plus negative 5. Just so I can see how it's behaving. So negative 5 times c is minus 5c. Negative 5 times negative 4 is plus 20, plus 2. And then we look to combine our like terms. So I've got f of c minus 4 equals, I only have one squared term, 3c squared. Although my c's, we have negative 24c and negative 5c, which will give me negative 29c. And then the numbers, we have 48, and 20 is 68, and 2 is 70. So what I've done is I've evaluated f of c minus 4, just showing you the process that's involved in plugging c minus 4 in for x. Now, what I would like to do is the following. Same equation or same function, f of x is equal to 3x squared minus 5x plus 2. And this time what I want to find is I want to find f of 1 plus h minus f of 1 all over h. That's my goal. That's my goal. So to do this, I'm going to break it up into pieces. I'm going to start with f of 1 plus h. So wherever we see an x, we're going to replace it with 1 plus h. So I have 3 times x squared, so 3 times 1 plus h squared, minus 5 times 1 plus h, plus 2. So when I'm doing the difference quotient, I think it helps to break it into its pieces. So again, 3 times 1 plus h squared minus 5 times 1 plus h plus 2. I need to do 1 plus h squared. So again, I'm going to go ahead and visualize that 1 plus h squared. Draw a multiplication box. 1 plus h, 1 plus h, 1 times 1 is 1, 1 times h plus h, 1 times h plus h times h plus h squared. Put all those together, h squared plus h plus 2h plus 1. So that gives me 3 times that, 3 times h squared plus 2h plus 1, minus 5 times 1 plus h plus 2. Now let us distribute. See what we get. 3 times h squared is 3h squared, plus 3 times 2h is 6h, plus 3 times 1 is 3. Again, with the minus 5, I like to make that plus negative just so I can see how this is behaving. So we have negative 5 times 1 is negative 5. Negative 5 times h minus 5h plus 2. Let's look for like terms. My h squared term, 3h squared. My h term, 6h minus 5h is 1h. And my numbers, 3 minus 5 plus 2, I think is just 0. So that's my f of 1 plus h. Now I also need f of 1. So let's look at that next. So what is f of 1? We see f of x is 3x squared minus 5x plus 2. So f of 1 is 3 times 1 squared minus 5 times 1 plus 2. And this worked out very nicely for us. So we get f of 1 equals 3 minus 5 plus 2. F of 1 is just 0. So putting all these together now, I want f of 1 plus h minus f of 1 over h. So what is that going to give me? F of 1 plus h is 3h squared plus h. So again, the first part there, 3h squared plus h, minus f of 1, which was 0, minus 0, all divided by h to get this version of a difference quotient. So we get 3h squared plus h divided by h. To finish this, we have to divide out factor, extract an h, and I am now left with 3h plus 1. Yes, h times 1 is h, all divided by h. And at this point, the h's divide out, and my result is 3h plus 1. And you will see for many problems, the process is essentially the same. So let's go ahead and make it just a little bit more challenging. Again, with our same function, f of x is 3x squared minus 5x plus 2. And why are we doing this? It's probably a question you want to ask. The difference quotient is very important for us in calculus. It helps us to define one of the most important tools we use in that course, namely the derivative. So it's helpful to be confident with this concept. So this version of the difference quotient I want is going to be f of x plus h minus f of x over h. And this is what we're going to be looking for. And we'll do our analysis to find out what that is going to be. And the key is to organize this effectively. If you do that, you'll have much greater success. Break it into pieces. The first thing I want to do is f of x plus h. So f of something, 3 times the something squared minus 5 times the something plus 2. What is the something? The something is x plus h. 3 times x plus h squared minus 5 times x plus h plus 2. Now this can get dangerous. There are many potential places where you could have difficulty with the computation. But the first thing I need to do is I need to do x plus h squared. So what is x plus h squared? What's that going to be? I like to Draw a square with x and h. Area is length times width. X plus h here, x plus h there. X times x is x squared. X times h plus hx, x times h plus hx, h times h plus h squared. So I get x squared plus hx plus hx plus 2hx, excuse me, x squared plus 2hx plus h squared. That's what x plus h squared is. The very common mistake students make at this level is they just say x squared plus h squared and forget those middle terms. Try not to make that mistake. So 3 times x squared plus 2hx plus h squared. And we get minus 5 times x plus h plus 2. And this again is f of x plus h equals this. F of x plus h equals this. 3 times x squared is 3x squared. 3 times 2hx is 6hx. 3 times h squared is 3h squared. I like to make minuses plus negative just to clarify what it means. Plus negative 5x is negative 5x plus negative 5h is negative 5h plus 2. And you will notice that there are no like terms here. Now go back and look at the original question. F of x plus h minus f of x over h. I have to subtract f of x. What is f of x? 3x squared minus 5x plus 2. So here's what I recommend. Write f of x underneath it. 3x squared minus 5x plus 2. And we are subtracting this whole thing. This whole thing is subtracting. So my next line is going to be f of x plus h minus f of x. 3x squared minus 3x squared, that divides out. 6hx, or subtracts out. 6hx is still there, plus 3h squared is still there. Negative 5x minus negative 5x is negative 5x plus 5x. That goes away. Then I get plus negative 5h, or if you prefer, minus 5h. I have 2 minus 2, that goes away as well. And that is my result for f of x plus h minus f of x. 6hx plus 3h squared minus 5h, because I lined this up in such a way that I can easily see how the pieces subtracted. And next I need f of x plus h minus f of x over h. So this whole thing all divided by h. 6hx plus 3h squared minus 5h divided by h. Then what we have to notice is I can factor out an h. In that top position, 6hx plus 3h squared minus 5h, there are h's everywhere. F of x plus h minus f of x over h. Let's factor out that h. What do I get? 6x, because h times 6x is 6hx, plus 3h squared divided by h is 3h, minus 5, all divided by h. And notice what happens here. We are very happy that the h's divide out. And my answer will be f of x plus h minus f of x over h equals 6x plus 3h minus 5. So that's a suggestion I will give you for doing problems of that type. Let's go ahead and do one more, maybe that's not quite polynomial in nature. This time, I will say g of x is 2 over x, and this time I want g of 1 plus h minus g of 1 all over h. So same process is involved. We're going to break it in pieces. What's g of 1 plus h? G of x is 2 over x, so it's 2 over something. 2 over what? 2 over 1 plus h. Okay. And what is g of 1? 2 over 1. So I need to do g of 1 plus h minus g of 1. G of 1 plus h minus g of 1 is 2 over 1 plus h minus 2 over 1. And this now requires us to get a common denominator. So we certainly can do that. Let's go find another piece of scratch paper. 2 over 1 plus h minus 2 over 1. How do we do that? 2 over 1 plus h minus 2 over 1. The common denominator is 1 plus h. To get from 1 plus h to 1 plus h and multiply by 1, 2 times 1 is 2. To get from 1 to 1 plus h, multiply by 1 plus h. Negative 2 times 1 plus h. Notice the 1 plus h would divide out and give you negative 2 over 1. So this gives me 2 over 1 plus h. This gives me minus 2. Make this plus negative 2, just so we're clear. Negative 2 minus 2h. So if we add all these together, then what's my result going to be? So 2 over 1 plus h plus negative 2 over 1 is 2 over 1 plus h plus negative 2 minus 2h over 1 plus h. And we get negative 2h over 1 plus h. So a lot of intermediate algebra involved there in terms of adding algebraic fractions. So that's what we get for our g of 1 plus h minus g of 1. So we get negative 2h over 1 plus h. Remember, we're not finished. What do we want to do? We want g of 1 plus h minus g of 1 over h. So how do we do that? G of 1 plus h minus g of 1 over h. Is all of this all over h, which I'm going to go divided by h to write it that way. All over h is the same as divided by h. So where does that put me? Where am I now? I have g of 1 plus h minus g of 1 over h is negative 2h over 1 plus h times the reciprocal of h. And you'll notice it's negative 2 times h, so that divides out. And my result is just negative 2 over 1 plus h. And that will conclude this lesson.